Hi, Assalamualaikum. My name is Ahmad Zalasmi. We are from Group 4. Our group will be presenting about the three-phase induction motor. So our group member is Ahmad Afif, Akmal Haris, Amir Haziq, Amza, and Yusuf Dafar. So in this video, we will talk about the definition of the three-phase induction motor, and the construction of the motor, and the operating principle, the three-phase induction motor type, and lastly the squirrel cage induction motor. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zala Hasmi. So, I will explain about the definition about the three-phase induction motor. So basically, the motor is an electromechanical energy conversion device which converts three-phase input electrical power into output mechanical power. So, the photo on the slide shows all the parts of the three-phase induction motor. So the main parts of the motor is the rotor and the stator. So the stator carries a three-phase stator winding, while the rotor carries a short circuit winding called rotor winding. The stator winding is supplied from a three-phase supply. The rotor winding drives its voltage and power from the stator winding through electromagnetic induction, and hence the name. So the three induction motors are the motor that most frequently encountered in industry because they are simple, low price, and easy to maintain. Such machine are called induction machine because the rotor voltage which produce the rotor current and the rotor magnetic field is induced in the rotor windings rather than being physically connected by wires. So in this video, we will cover the principle of the three-phase induction motor and explain how this motor works. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amza, and now I will continue our group presentation with explanation about construction of three-phase induction motor. Three-phase induction most widely used electrical motor, and almost 80% of mechanical power used by the industries is provided by three-phase induction motor. It is because of its simple construction, good operating, and low cost had become a good choice by industries. The induction motor also called as a synchronous motor as it runs at speed other than the synchronous speed. Three-phase induction motor have two main parts, that is stator and rotor. The first main part was stator. It was named stator because it was a stationary part of the induction motor. The stator is built up of high-grade alloy steel aluminum to reduce current loss. Stator has three main parts, that is outer frame, stator core, and stator windings. We can see clearly from the diagram that was attached here where is all the main part is located. Next, the stator frame is the outer part of stator. Its main function is to support the stator core and the field winding, and also provide protection to the inner parts. The frame is either made up of die-cast or fabricated steel. Frame should be strong and rigid as the air gap is very small. The second part was the stator core. The main function is to carry all the alternating flux. The core is laminated to reduce current loss, and laminated type is stamping 0.4 to 0.55 mm thick. The stamping is made up of silicon steel that reduce hysteresis loss that occur in the motor. Lastly, the last part was stator winding. The slot on the core carry three-phase windings. Three-phase windings are either connected in star or delta. Squirrel cage is delta connected, while strip ring can be both delta and star connected. The last part of three-phase induction motor was the rotor. Rotor is the only part that moving by rotating and connected to the load through shaft. It is also built as thin lamination that is same material as stator. Stator and rotor was separated by air gap.
Assalamu alaikum wa rahmatullahi wa barakatuh. I am Yusuf and I will explain about the winding part. So as you can see, we have two types of winding, which is the stator winding and the rotor winding. Okay, so the stator winding. Moving on, we have the stator winding is also known as initially the rotor inductor winding. Stationary. So what happens is, but there is a relative motion between being connected to a three-phase. So as you can see in the diagram, there is a rotating magnetic field red being formed, which is the RMF, which is also called the RMF. So now, because the rotor is rotating magnetic field rotates, it rotates around the stator at so because of current flowing, and there is a magnetic field, and this is the formula for is being formed. You can see the frequency. Once this magnetic field divided by the number of poles, it creates a mechanical force. So this is the stator winding. Okay. So this mechanical force, the stator winding is also known as this mechanical force inductor winding. Creates so what happens is it results in a torque stator which moves the rotor in the same direction as the RMF. There is a rotating and eventually field being formed, the which is induction the motor, which is also called the RMF. So as you can see here, moving on, we have the rotor winding. So initially, the rotor is stationary, but there is a relative motion between it and the RMF. So as you can see in the diagram, the RMF, which is shown in red, goes through the air gap and cuts the rotor. So now, because the rotor is short-circuited, current begins flowing in it. So because of current flowing, there is a magnetic field. A magnetic field is being formed. So once this magnetic field is formed, it creates a mechanical force. Okay, so this mechanical force, the sum of this mechanical force creates a torque. It results in a torque which moves the rotor in the same direction as the RMF. Okay, and eventually the induction motor begins rotating.
Assalamualaikum. My name is Akmal Haris, and I will explain about how does the three-phase induction motor works and operates. Before we understand how it operates, we need to understand some of its basic concept first. So based on an animation that I have prepared, the first understanding that we need to understand is when we pass a current through a wire, an electromagnetic field will generate. So based on the second animation, if we put the wire between a permanent magnet, the wire magnetic field will interact with the permanent magnetic field. So the wire will experience a force going upwards or downwards. It depends on the direction flow of the current or the magnetic field polarities. Next, when we wrap the wire into a coil, it will produce a stronger magnetic field and will generate a north and south pole like a permanent magnet. But in the next animation, it explains about when we pass an alternating current, the polarity also alternates. So we can see it move like the fourth animation. So another concept is when we place another separate coil in a close proximity with the coil that have a AC current pass through it, the second coil will produce a current which will be induced by the first coil. So this is the concept we need to understand. I will explain how does the three-phase induction motor works. First of all, on the first animation, we can see that we connect two coils together to create a larger magnetic field. And in the middle of the coil, we put a closed loop wire. So if we pass an alternating current through the coil, it will induce a current in the closed loop wire in the middle. So the closed loop wire and the coil will have its own magnetic field. So as we understand before, if it's if the wire is magnetic field is in between a permanent magnetic field, it will experience a force, whether it's going upward or downward. So as we understand before, if there is a wire that generates electromagnetic field in between a permanent magnetic field, the magnetic field will interact each other, and the wire, the closed loop wire in the middle, will experience a force, whether pulling or pushing. So this we can see that the closed loop wire will be rotating, uh, and we can call that the closed loop wire as a rotor, and the coil is a stator. But with only two coil, we can see that the closed loop wire in the middle will be jammed, because the alternating current will be aligned at the middle, and it cannot rotate fully as the current is alternate, so it will be jammed at the middle. So to overcome this, we need to add more coils. For instance, in the animation tree, the three-phase induction motor use three sets of coil. So when we pass an AC current through it, we know that it will produce an electromagnetic field and the polarity and its polarity. So not only that, we connect the coil, three different coil, in a phase, so that the polarity and magnetic field can occur at a different times. So how does we distribute it? To be exact, we connected the coil in a phase of 120 degree. So it can rotate perfectly the motor. So this is why a three-phase induction motor is a self-starting, because it does not need any external force to rotate it. It only uses an electromagnetic field generated between a coil, who acts like a permanent magnet, and a closed loop wire in the middle, which interact with the magnetic field of the permanent magnet. And so this is how three-phase induction motor operates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Afif Hakimi bin Aznan, metric number 2014907, and now I will explain about the types of three phases of induction motor. So there are two types of three-phase induction motor, which is squirrel cage induction motor scheme and slip ring induction motor stream. And as we can see in the picture in the slide, the left one is the motor of the squirrel cage induction, and the right one is the slip ring induction motor. Firstly, it is called squirrel cage induction motor because the shape of rotor resembling the shape of the cage of a squirrel, and the construction of this motor is simple and rugged. Hence, it is almost 80% of induction motor is using the squirrel cage type. For the slip ring induction motor, it is also known as wound rotor induction motor. The rotor winding is wounded such that the number of poles same as the stator winding, and the end terminal of rotor windings are connected to the slip rings. Thus, this motor is known as the slip ring induction motor. Both the squirrel cage and the slip rings is using cylindrical laminated core, and for the squirrel cage, slot on the outer periphery is skewed at some angle to prevent the magnetic locking between the stator and the rotor teeth. Hence, smooth the operation and reduce the humming noise. And for the squirrel cage, it is also consists of rotor bars. Instead of rotor winding, rotor bar is used, and the material is aluminium, brass, and copper, for example. And the rotor bar are short circuit, so it cannot add external resistance to the rotor circuit. And for the slip rings, it is semi-closed slots on outer periphery that carry three-phase insulated windings, and the external resistance can easily connect to the rotor circuit. So through the slip ring brushes, and the external resistance is useful to control the speed of the motor and starting torque of the three-phase induction motor. And the external resistance used for starting purpose only. And when the motor speed is near the actual speed, the slip rings will be short circuit by the metal collar. And the maintenance of this motor is small, so this motor is only used when the variable speed control and high starting torque are needed. Otherwise, the squirrel cage is used. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Hazid Abdirazak, and today I would like to talk about the squirrel cage induction motor. So, to put it simply, the squirrel cage induction motor is actually a type of three-phase induction motor which function based on the principle of electromagnetism. This name of squirrel cage is actually inspired by the cylindrical shape of the rotor used in this induction motor. So this rotor is a cylinder of steel lamination with highly conductive metal. Typically, we will use the aluminium or copper that embedded into its surface. When an alternating current is run through the stator winding, a rotation magnetic field is produced. This induced current in the rotor winding, which produces its own magnetic field. The interaction of the magnetic field produced by the stator and rotor winding produce a torque on the squirrel cage rotor. The squirrel cage induction motor also has an additional component of fan and bearing. A fan is attached to the backside of the rotor to provide heat exchange, and hence it maintains the temperature of the motor under a limit, while the bearing are provided as the base for rotor motion, and the bearing keep the smooth rotation of the motor. Next, I would like to talk about the advantage and the disadvantage of the squirrel cage induction motor. So as you can see here, the advantage, they are low cost, require less maintenance as there are no slip ring or brushes. It also has a good speed regulation because they are able to maintain a constant speed, high efficiency in converting electrical energy to mechanical energy while running, not during startup, have better heat regulation. As you can see before, it has a fan, so it don't get as hot. It is small and lightweight, and the is explosion proof as there are no brushes while eliminate the risk of sparking. In contrast, the disadvantage has a very poor speed control. Although they are energy efficient while running at full load current, they consume a lot of energy on startup. They are more sensitive to fluctuation in the supply voltage. When the supply voltage is reduced, induction motor draws more current. During voltage surge, increase in voltage saturates the magnetic component of the squirrel cage induction motor. Lastly, they have high starting current and poor starting torque. The starting current can be 5 to 9 times the full load current. The starting torque can be 1.5 to 2 times the full load torque. Although the squirrel cage induction motor are used a lot in industry as they are reliable, self-starting, and easy to adjust. These motors are commonly used in centrifugal pumps, industrial drive, large blower and fan, and machine tools, and maybe lathes and other turning equipment. So I think that's all from us, Group 4. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.